Okay, so we're going to be looking at the basics of quantum numbers. I put this chart at the bottom of the Chapter 4 notes, and it kind of tells you in a slightly different way what each quantum number is telling us. Well, let's remember that we have the 4, and we'll get to those. Well, let's do that right here. It says list the 4 quantum numbers by name. We have the principal quantum number, what we've been abbreviating N. We have what's called the angular or angular momentum quantum number that we've been abbreviating L. We have what's called the magnetic quantum number that we've been abbreviating M sub L. And the last one we have, which is called the spin quantum number, which we've been abbreviating M sub S. And what does each of them tell us about where we can find an electron in an atom? Well, we know N is kind of like the floor of the atom that we're on. We'll say energy level. It's analogous to the floor of a hotel, you might say. Angular momentum is going to tell us the shape of the orbital. That'll make more sense tomorrow, but for right now, you could kind of call it the type of the room you're in. Are you in a corner suite? Are you in a regular one? What we're going to call the magnetic quantum number, M sub L, is kind of like which way the room is pointing, what we call orientation. And finally, spin, M sub S, is what direction is the electron spinning. And there's only two real options, up or down. You'll see this chart kind of corroborates that. It says N is our printable number, tells us the energy, the floor. Angular momentum tells us, it says, contributes to angular dependence and to a lesser extent energy. What we want is that word shape. That'll make more sense tomorrow. M sub L is the magnetic number. It determines the orientation of the room we're in, the shape. And finally, the M sub S is the spin. We're not so much worried about those, but that gives us the ability to answer question number 1 a bit more. Quantum numbers, we could say, are how we determine, we could call it the address of an electron in an atom. Where are we going to find our electron? It is at energy level 1. Is it in a particular shape orbital? Is it spinning up? Is it spinning down? And this term, main energy level, N, is simply, excuse me, I'm waiting for my projector to start up, what floor? If we are using this diagram, you might interpret floor being how far away from the nucleus are we. Energy level N equals 1 is closest to nucleus, and so on and so forth. Remember that we are going all the way up to 7. Okay, let's get back to our original document. So now that we kind of know how those work, let's take a look at question number 3. It says we know the principal quantum number N can be any value from 1 to 7, and we also know that the angular momentum quantum number L can be any value of less than or equal to N minus 1 all the way down to 0. If the magnetic quantum number M sub L can be any whole number value from negative L to positive L, what positive values of M, I should say sub L, could exist at energy level N equals 4? So, when we're at energy level N equals 4, the possible values for L can be anywhere from 0 to N minus 1. That would be, if N is 4, N minus 1 would be 3. So our values for L could be anywhere from 0 to 3. That means we could have 0, 1, 2, or 3. Each of these is going to be our shape of orbital. It's asking what possible values of M sub L could exist. So here's how we're going to do that. M sub L can be anywhere from negative L, that needs to look like an L, not a 1, negative L to positive L. All right, well, let's remember that for energy level N equals 4, we have 4 values of L, 0, 1, 2, and 3. It means the possible values for M sub L for when L is equal to 0, well, then M sub L for 0 can only be 0. M sub L for 1 can only be negative 1, 0, or positive 1. M sub L for 2 can only be negative 2, negative 1, 0, positive 1, or positive 2. And M sub L values for 3 can only be negative 3, negative 2, negative 1, 0, positive 1, positive 2, positive 3. These are the possible values for m sub l. That means that there are, let's count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 possible values for m sub l. It will make more sense tomorrow. Let's do the last question. How many instances in which m sub s equals negative 1/2 could be present in energy level 2? Remember that m sub s is simply spin. Which direction is an electron spinning? So an electron with m sub s equals negative 1/2, that's just a fancy way of saying that this is an electron that is spinning in the down direction. That's all it means. So before we answer this question, let's find out what possible values for m sub s we could have at energy level n equals 2. We know n equals 2, and that means L can only be 0 or 1, anywhere from 0 up to n minus 1. It means our possible values for m sub L can only be 0, because of course that's the L value. If our L value is 1, then our possible values for m sub L are negative 1, 0, and positive 1. Each of these is an orbital that can hold 2 electrons. So this orbital can hold 2 electrons. One of them has to be spinning in the down direction. We'll call that negative 1/2. And the other has to be spinning in the up direction. We'll call that positive 1/2. This orbital can hold a down spinning electron, and it can hold an up spinning electron. I'm sorry, that's not an orbital, that's L. This is an orbital. This can hold a down spin electron, and that can hold an up spin. This one can hold a down spin and an up spin, and this one can hold a down spin and an up spin. So we've got a negative 1/2, that's a down spin here, 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 and here. How many instances in which m sub s equals negative 1/2 could be present at energy level 2? 4. M sub s equals 1/2 electrons. In other words, you've got 4 electrons that are spinning in the down direction. And that's all you do. Okay? See you tomorrow.